Hello, and welcome to today's webinar on the Clean Energy Cybersecurity Accelerator and Cohort 1. In just a moment, you'll hear some opening words from leadership from the U.S. Department of Energy and our industry partners. But first, I'd like to share the agenda for today. We're going to kick it off with some opening remarks from the DOE. We're then going to get into the vision of the overall program for the accelerator. We're then going to have a short discussion on national security priorities, then get into the theme for Cohort 1. Then we're going to talk about the overall cycle and what we're expecting from the cohort, how we do our technical evaluation, and wrap it up with how to apply and some questions and answers. With that, let's kick things off by turning it over to our colleagues at the Department of Energy, Berkshire Hathaway, and Duke Energy.
Hey there, welcome everybody, and thank you for joining me today to learn more about an exciting opportunity to engage with DOE, with the National Renewable Energy Lab, and with our utility partners. I am Kelly Speaks-Bachman, and I lead the Office of Energy Efficiency and Renewable Energy, or as we like to say it, EERE. Now today we've reached an exciting milestone with the Clean Energy Cybersecurity Accelerator, or CECA, a public-private collaboration designed to catalyze the development of cyber solutions for the clean energy grid of the future. Since our Deputy Secretary of Energy, Dave Turk, announced CECA last October, the Energy Department has worked with NREL and our utility partners to prepare the physical and operational infrastructure to be able to test and validate this first cohort of cyber solutions to address specific cyber threats to our energy systems. And so now we are ready to move forward. But before we move forward, let's take a step back, because I want to just lay out for you all, as many of you know, President Biden set ambitious goals to cut emissions in half by 2030, and for us to reach 100% clean grid by 2035. So we know that action's needed now if we're going to secure that transition to clean, resilient energy systems and a fully decarbonized grid. We also know that cyber attacks are really getting more frequent, they're getting more sophisticated, and they're getting more dangerous, as we've seen by numerous events in the news. The effort to accelerate deployment of cybersecurity solutions for the energy sector is a top priority for the department. And over the past several years, my office has invested millions of dollars in the cyber range at NREL's Advanced Research on Integrated Energy System, or the ARES facility. And now, in partnership with some leading utilities and with our sister DOE office known as CESAR, focused on cybersecurity, we're really excited to be able to offer a testing platform for innovative cyber solutions. We have to secure clean energy systems to be able to support the nation's transition to clean energy, because if we don't, there's going to continue to be roadblocks that really impede that evolution to a decarbonized grid. So whether you're a cybersecurity solution provider, an electric utility company, a researcher, or another type of stakeholder, I am glad you decided to join us today to learn more. So thank you for your interest in the program, and I hope you enjoy the session.
Thank you, Kelly, for the great introduction, explaining the importance of the Cyber Accelerator and why we're here today. I'm Piyush Kumar, and I lead the department's Office of Cybersecurity, Energy Security, and Emergency Response, or CESAR. I echo everything Kelly said. The effort to accelerate deployment of cybersecurity solutions for the energy sector is a top priority for the department. And we must secure the clean energy systems that we are working hard to expand if we are to support the nation's transition to a renewable, reliable, and secure energy future. I'd like to start by thanking those in attendance today. This is an exciting time at the department. And as we work with partners like you, the national laboratories like NREL, to tackle cybersecurity and climate change challenges through innovative solutions like the Cyber Accelerator, we need everyone coming together to work on this. We need industry, we need manufacturers and suppliers, we need cyber vendors, and yes, we also need academia to come along and really partner with us as we tackle these grand challenges. The Cyber Accelerator is one such solution. It supports the President's National Security Memorandum on improving cybersecurity for critical infrastructure control systems that was issued last year. The memorandum calls on government and industry to work together on our shared responsibility to mitigate cyber threats to systems that control and operate critical infrastructure on which we all rely. In CSER, we are focused on securing the energy sector from all hazards. We're looking at everything from cyber attacks to physical security and natural hazards like wildfires and hurricanes. We really are looking at the entire gamut of risks that is facing the energy sector in the United States. Through the Cyber Accelerator, technology innovators like you will have a platform to develop and deploy renewable, cost-effective, and secure grid technologies with a pathway to technical validation and demonstration. This will help us accelerate cyber solutions like never before. Our focus is to work closely with the energy sector and partners like you at the Cyber Accelerator to deliver clean, secure, and reliable energy into homes and businesses across the country. I'm optimistic that innovations from the Accelerator will meet the nation's energy security needs for the coming decades. Thank you for being here today and engaging with us in the Cyber Accelerator. Only through close collaboration between government and industry can we achieve a clean, secure, and reliable energy future for the country. Thank you.
The rate of innovation in the energy sector is accelerating. As we commit to ambitious goals to transition to clean energy, we're also fundamentally changing the way the grid operates. The grid was originally designed to produce power and send it to our customers in one direction. But today, customers might have distributed energy resources like rooftop solar or electric vehicles that feed power back to the grid when needed. We also have utility scale solar farms, wind farms, battery storage. We're rapidly evolving to a distributed and bidirectional grid. As we build that future grid, we need to tie into some decades old systems that weren't built with cybersecurity in mind. That infrastructure can't be replaced overnight, so there's a transition period where we need to commingle the old and new. This first cohort is looking for solutions to some of the concerns we face as we make the transition. Specifically, we're looking for solutions to address the lack of strong authentication and authorization within distributed energy environments, and especially solutions that can help secure older field devices that may lack strong authentication. We want to help guide the solutions that are needed and accelerate bringing products to market so we can not only keep up with the pace of change to the grid, but also stay ahead of OT cyber threats that are increasing every day. This partnership between industry, the government, and the private sector is, I think, the most effective way to simultaneously transform and protect the grid.
We are excited about vendors applying their security practices and tools in a different and unique way, really focusing on operational technology, protecting the grid from transient devices, and adding a layer of authentication that is missing in today's market. Through the Cyber Accelerator, we hope to move these previously unapplied resources to our energy systems in a way that enhances not just critical infrastructure security, but national security.
Thanks, everyone. And now John White, the director of our cybersecurity program office, will introduce the program vision. Then we're going to have Sherry Cady talk about the impact on the program to national security. Ryan Brubaker, the program manager at NREL, will talk about the program at large and how we expect it to play out and work. And then Jared Macon will talk about the execution of our processes and how we'll be testing applications. But first, we have Jonathan White. He's the director of our cybersecurity program office here at NREL, and he's going to give us his vision of the program.
Thanks, Dave. And I want to reiterate, as our previous speakers have well covered, how exciting today is for all of us involved in the Accelerator. We are honored with the opportunity to lead this critical effort on behalf of our amazing electric utility partners and our colleagues at CSER and ERE. In our current grid environment, energy technologies are rapidly transforming to support a grid that's highly distributed, intelligent, and will lead us to a decarbonized future. But while this transformation is occurring, cyber adversaries continue to advance their ability to threaten our electrical system and find new ways to access the modern grid, clearly evident by the activity we've seen this year. We developed the Cyber Accelerator to secure the energy transformation by system design and innovate at a speed that will outpace the emerging threats. The vision for this program came out of the input from utility partners, demonstrated success in other energy sector accelerators, and availability of the Aries Cyber Range here on NREL's campus. As we move forward on the accelerator, we hope to tackle growing challenges around scaling, ownership, and supply chain that are unique to the energy transformation. For example, with the rapid increase in quantity and diversity of connected devices operating autonomously, we will need to provide system-level security solutions to overcome component weaknesses. With more and more grid assets that are customer-owned, the ability to monitor, maintain, and secure assets directly will become increasingly difficult and necessitate new ways to incentivize these best practices. With little control of the technology supply chain, it will be critical to carefully assess the trustworthiness and authenticity of new hardware and software for grid edge devices and services. To achieve this vision, we are looking to bring on more utility partners, increase the number of cybersecurity cohorts operating in parallel, and decrease the cycle time from start to finish for each accelerator cohort ahead. We're thrilled to reach this milestone and officially launch the first cohort for the accelerator after months of hard work for all those involved to ensure the program's processes and assessment will lead to consistent and invaluable impact. So thank you to the team for all your hard work in reaching this milestone, and thanks to all you in attendance for your interest in the accelerator and joining us today.
Thanks, John. Now we're going to have Sherry Caddy, who is a senior advisor for cybersecurity at CSER for the Department of Energy. She's going to speak to our national cybersecurity priorities.
Great, thanks, Dave and John, and thanks to everybody again for joining us today. Echoing all of the speakers previously, we're really excited about starting this new program, this new and innovative program. And as a cybersecurity professional, I can tell you that generating the unity of effort from a lot of disparate stakeholders to achieve cyber ends is so critical, not just public-private partnership, public-private research community, all hands on deck have to be on this mission to make real progress. And the Cybersecurity Accelerator is a really great program for that reason. It brings together our government experts, our research experts at the national labs, and the national cyber range that they have put together that is an unparalleled resource for us to make available to our industry partners and technology providers. So industry, technology, government, academia, and research really bringing together that critical unity of effort that is needed to meet our cyber threats. And as others have mentioned, our cyber threats, alas, they're not getting any easier or less. And as we look at global tensions occurring in the world, we know that our grid is not only been under attack, but is under increasing threat. So it's really critical that we bring together the partnership and accelerate our ability to test, validate, verify innovative solutions in cybersecurity that are going to be able to secure our grid of the future. So bringing together that unity of effort, accelerating the ability to test and validate these solutions and accelerate their adoption by our utility asset owners is just so critical for national security. So I want to thank everyone for participating today in this innovative program. I see we're already getting questions, so that's fantastic. So we look forward to a really great interactive session today. So back to you, David. Thank you.
Thanks, Sherry. So my name is David Benton, as you know. I'm the Partnership Development Manager for the cybersecurity program here at NREL, and I'm going to talk for a few minutes about the theme of Cohort 1. The theme is strong authentication adapted for distributed energy resources. So you may ask yourself, what does that really mean? We're looking for solutions that address the risks created through that lack of strong authentication within these systems. Many times within the utilities, we've got legacy devices that can't support strong authentication. We're not sure how those accounts are tracked and logged. We're working on different ways these systems are interconnected with legacy grid systems. The authentication there is typically weak. And then when you talk about authentication and authorization of the commands that take place within the grid and between these distributed energy systems, there's also typically a lack of strong authentication. So this is the high level description. We've been intentionally left it really high level to cast a wide net and see what solutions are out there that may apply to these situations and these problems. One other point I wanted to make on this is, if you're a solution provider and you're saying to yourself, well, I've got a really cool solution and it's never been applied to a non-energy type application, we still want to hear from you. So please, if you think you're going to fall into this, if you're going to be able to solve these problems, we do want you to apply and we'll take a look at your solution. Next slide, please. And for some context, if you're still having a question, does my solution apply? We are utilizing the MITRE ATT&CK framework for industrial control systems as part of the overall program. And the mitigations listed on the left are the mitigations we're seeking solutions for. So if your solution potentially applies to one or more of those mitigations, we definitely want you to apply. Thank you. And now Ryan Brubaker, our SECA program manager at NREL, is going to talk about the SECA cohort cycle.
Thanks, Dave. Hi, everyone. Thanks for joining us. The excuse me, the SECA cohort cycle is designed to develop themes that are based on the highest risks that we've identified with our utility partners, so we can be relevant and apply these solutions to current and future threats for the grid. Slide, please. The cycle begins with prioritizing these threats with our utility partners along with the Department of Energy. And we develop a theme for each cohort. And then we launch into an application period, which just opened on Monday. And from there, we will conduct a down select process to select the solutions for each cohort. And then from there, we're going to conduct a technical assessment. Right now, the first cohort, it's going to be a 6-month technical assessment. The time frame is going to change depending on the solution, as well as the theme identified for each cohort. It could be as short as 3 months, or if it's something more complex, it might take us a full 12 months. So it really will depend on the theme and how we scope that particular cohort. And then finally, at the end, the solution provider, you'll be provided with a comprehensive report on the technical assessment, as well as an opportunity to engage with the utility partners on delivering for the market. The key stakeholders there you can see, which has already been discussed, are utility partners, you as the solution provider, and the Department of Energy, that are all in this joint program. So it's really an exciting and unique program in that aspect. Slide, please. So to identify our themes, we've broken it down into 3 different categories. The first is the core criteria, which is developed with our utility partners, Department of Energy, and the SECA team here at NREL. And what we're trying to do is we're trying to identify themes that we can use for the current risks that the grid face, as well as the future risks that will be faced by more distributed energy and more renewable resources, renewable energy resources that are on the horizon. Next, we overlay this with national security considerations, and those are provided by the Department of Energy. And then finally, any technical considerations that maybe we need to expand our range, or maybe we need to add some particular hardware to accommodate the theme for that particular cohort. We're willing to adapt and modify the range as needed. Slide, please. And next, I'll pass it over to Jared. He is the Cybersecurity Evaluation and Application Group Manager for the technical assessment of our process, and he will describe more about the assessment process.
Thanks, Ryan. So I'm going to talk a little bit about our assessment approach and talk through how we're going to evaluate these solutions, but want to start by touching on some of the capabilities at the lab that really make this possible. So we can go to the next slide. So the one of the foundational components of SECA is the Aries Cyber Range. Cyber Range provides us a platform for developing and deploying cyber physical environments to really enable test and evaluation. From the diagram you see here, you get the idea of what this allows us to do is take virtual systems that are hosted within the compute resources of the range and combine those with physical assets that are hosted across the lab campus. And that allows us to create a unified environment where we can go and perform experimentation and assessment. So this gives us the ability to virtualize and emulate and visualize energy systems, including the power systems layer, as well as the communications and control system layers, and then subject them to various disruptive scenarios. Once we have that environment developed, those virtual environments can be rapidly deployed and then redeployed as needed, which sort of makes them ideally suited for a program like SECA, where we, by design, are intentionally going to disrupt them. The net result is really a controlled environment to perform threat emulation and assessment in a safe, efficient manner, where we know we're not going to disrupt any kind of real-world operations or systems. For SECA specifically, this gives us the ability to create environments that are tailored to the cohort topic, and then we can adapt them to solutions that are undergoing assessment, really adjust to meet the various fidelity needs and architecture requirements, as well as hardware integration. We can jump to the next slide. So we, from an assessment process, we have divided into 3 phases. Our first phase is really focused on the build out. So we take the range that we just talked about, and then use that to deploy a suitable environment to host the solutions that are undergoing assessment and accommodate the threat emulation model that we intend to apply. Our intent is to develop a common environment for the entire cohort where we can support the varied solutions that are ultimately selected to undergo the assessment process. So not tailoring environments to individual solutions, but finding that common shared environment. Second phase would be moving on to the actual assessment, which is where we will iteratively deploy each solution free from competing security implementations, so we can focus on the particular solution being assessed and execute that threat emulation plan derived from associated TTPs. So each solution is going to get assessed independently. We're not looking to co-deploy or co-locate or integrate solutions, but rather deploy each one and assess them on their own. Then that final phase is the reporting, where we will take the gathered data and the observed performance of the solutions and document that. So I'll dive a little bit more in detail into these phases. Go on to the next slide. When we think about the build out process, we really see this as a collaborative process where, through coordination with the selected solution providers, as well as the sponsoring utility stakeholders, we're going to design and deploy an appropriate environment that meets the dependencies of the solutions that are identified, as well as providing a relevant representation for our utility stakeholders. We want to ensure that they can extrapolate from our assessment process in our virtualized environment to real-world implementation within their operating environments. Given the time and complexity that can be involved with this process, our team really look to leverage existing models, reference designs that we have available, and then layer on the dependent elements to make adjustments to really support those solutions, and then the threat emulation scenarios that are going to be outlined. The environments themselves are going to be scaled appropriately to support the technologies under assessment, really to ensure that we get sufficient fidelity for this specific cohort. So what that really means is we're not seeking to deploy a broad, large-scale distribution environment if what we really need is to focus on a small, high fidelity scale environment to really focus in and zoom in on the particular problem at hand. Move to the next slide. So once we have that environment deployed, we'll move into our second phase, which is really the assessment. And during this phase, we will focus on that assessment via threat emulation. Our threat emulation plan is, again, going to be developed in coordination with our stakeholders and solution providers by drawing from the relevant MITRE ATT&CK TTPs. David mentioned at the beginning of this, we provided 6 mitigation techniques from MITRE ATT&CK that are tied to the concept of strong authentication and authorization. Associated with those mitigation techniques are roughly 26 TTPs, so adversary tactics and techniques, that we will draw from to build out that threat emulation plan. We don't intend to use all of those tactics. We will instead identify those that are best aligned with the solutions that are identified and that address the needs and concerns of our utility stakeholders. So what this really means is that rather than full adversary emulation, attempting to go, say, replicate a particular APT, instead we are focused on a set of tactics and techniques that are of specific concern and are aligned with the expected capabilities of the solutions being assessed. So we're looking to evaluate solutions' ability to support specific mitigation rather than performing a comprehensive solution evaluation. So it might very well mean that there are capabilities and features of one of your solutions that won't be assessed as part of this, that might fall outside the scope. And we want to narrow in on that set of tactics and techniques and see how does it help address those. It's also important to note this isn't a pen test of specific solutions capability or specific solutions. Certainly, if we were to find something and during the process, we document and share that appropriately, but we're not focused on trying to find vulnerabilities within these solutions. We're really looking at how can they help address the tactics and techniques of concern as kind of outlined in this example here. So each solution will be deployed into this environment during this phase individually and assessed with that identified threat emulation plan. We go to the next slide, please. And so what we're really looking for is solutions that can help break that chain. And so when we use this example scenario here in this diagram, see a notional solution that has addressed techniques related to the collection tactic. But in reality, we can see solutions that might shift to the left and address initial access or lateral movement, or shift to the right and perhaps provide authentication around DMP3 commands and address some of the impairment of process controls. Or in all likelihood, we might see solutions that are addressing the spectrum of techniques and can address techniques at kind of all phases of a scenario such as this. What we want to stress is we're not looking for solutions that will address all of these. We're really looking for those that can help break this chain at various stages within the overall threat model. A few considerations when you're applying technical dependencies. The more we can gain insight into the solutions, the more that will help understanding how we can incorporate your capabilities into the environment. So what's needed for your solution in the deployment environment? What are the compute needs, the operating system requirements, external dependencies or hardware integration? Do you have specific expected kind of user or environment activities or behaviors or traffic types? How is your solution deployed? How is it? Can it be virtualized or is it cloud-based? How is it configured and tuned and optimized for a given environment? All those will really help us understand how we build out an appropriate environment and also how we can integrate it within the in-rel cyber range. So finally, moving on to the last phase, to the next slide. Our final phase is reporting. And I think this is, while the most straightforward, it is also the most important. And we will generate reports on a per solution basis that will encompass the environment that was established for the assessment, document the threat emulation procedures that were executed and the performance of each individual solution. So each solution will receive its own report with no comparisons drawn between solutions. That final report will include the technical detail on the specific procedures that were executed, the observed behaviors of those solutions, as well as the collected data that can corroborate what was observed for clarity and reproducibility, should that be an issue. We fully expect to be engaged with the solution providers during this process so that should there be an area of concern or something unexpected, that we can be discussing and to ensure that it's not a result of sort of misconfiguration or deployment. And ultimately, those reports will be made available to our DOE sponsors and utility stakeholders, as well as certainly solution providers themselves will receive their respective reports. So with that, I will turn it back over to Ryan to talk about how to apply.
Excellent. Thank you, Jared. Slide, please. The application process is fairly straightforward. We're using a application portal called Momentive. We will provide the link in the chat. You can also find it at our website. But basically, you go to the application portal, review the application guidelines and eligibility criteria, and we ask that you would upload a video, a 1-minute video approximately, of your solution. And this is really an opportunity for you to showcase your solution and why you think it fits with this cohort and why we should select your solution. And then finally, complete the application and submit it by July 6th. Slide, please. And the eligibility requirements are fairly basic. We ask that the solution be headquartered in the United States, and that you address the theme, which is strong authentication for distributed energy resources. And then finally, that your solution is at a TRL or technical readiness level of 4. And we provide the guidelines for that in the application portal and on the application guide as well. Slide, please. The timeline is the application is open now until July 6th. And after the application period closes, we will begin our down select process with our utility partners. And we will select the solutions for the first cohort, and we'll announce our selections in September. And we plan to begin the technical assessment in October, which should last about 6 months through 2023. Slide, please. If you need any additional information, you can email the seca@nrail.gov inbox, or you can go to our website, and we'd be happy to answer any questions that you have during your application. Or if you have any technical issues, anything like that, reach out and we'd be happy to help you out if possible. So that concludes our discussion or our presentation. Now what we'd like to do is have a discussion, open it up for questions and answers for anybody that would like to ask questions of the panelists, or might want some clarification on the application or the technical assessment, anything that, that you might need to ask.
Thanks, Ryan. We've got a couple of questions coming in the chat. We're working on some answers, but just to get things started. Question one was, how can we learn more about the technical details of cohort 1, and where can I send questions? I think Ryan just answered the questions with the SECA mailbox, so that one's easy. But when we're talking about technical details for this cohort, we really intentionally kept it high level to encourage applications and solution providers to bring their solution forward. We can add that the utility models that we are working with are based mostly on the Purdue model and current interfaces that a typical utility sees within distributed energy. Hopefully that helps a little bit in terms of context and how your solution might fit. For question 2, Ryan, I'm going to ask you to answer this one. Question is, my solution has never been tested in the energy sector or within distributed energy resources. Am I still eligible for the program?
Yeah, thanks for the question. I would say yes, and we understand that this is a relatively new area for a lot of solutions. There hasn't been a lot of focus in this area in the past. And so we understand that there's not going to be an exact fit for this theme. Again, as David talked about, we try to keep it fairly broad so we can accept innovative and outside the box ideas for this type of risk that we're trying to address. So review the MITRE attack for ICS that we've talked about. Ask questions, but absolutely, I would say apply it. It doesn't hurt for you to apply, and we could probably provide some feedback. That way you can, it'll help you in the future. So if in doubt, I would say absolutely apply.
Great, thanks, Ryan. The next question we have coming in, I'm going to direct towards Sherry. The question is around, how does SECA fit in with other Department of Energy efforts?
Thanks. I think the Department of Energy, of course, has a wide-ranging set of issues. I think you've heard a lot about them this morning. We're both accelerating the adoption of clean energy, decarbonizing the grid, and then also we're pursuing cybersecurity solutions. And so we have a number of programs for which this particular initiative fits into. And on the cyber side, we have programs related to cyber vulnerability testing for individual components. This is a little bit different because we're talking about cyber solutions in a simulated environment, but we very much are bringing those programs together. We also are really working hard, again, from a cybersecurity and critical infrastructure resilience perspective, on accelerating and infusing principles of security by design. And we are about to release, very excited to talk about, we're about to release next week a congressionally directed national cyber-informed engineering strategy that's really going to present a roadmap to introduce more security by design into engineering, the engineering community in the energy sector, as well as other engineered solutions. So this SECA program is very much being designed to fit into our cyber supply chain, cyber protection, cyber threat intelligence, and of course, our overall efforts to design, build, secure, and make the grid more resilient and more carbon free. So it's definitely mindfully designed to dovetail with all of those things.
Thanks, Sherry. We've got a few questions on funding availability to solution providers. Ryan, do you mind answering that one?
Yes, not a problem. So currently we are, the utility partners are funding the technical assessment portion of each cohort, and funding to the solution providers is not built into that at this point. However, we understand that there could be the need for that in the future. So we do have an open dialogue about that, but for cohort 1, we don't plan to have funding for the solution providers. However, you will get access to the NREL range as well as staff. You'll get exposure to the utility companies, and really you'll get excellent feedback on your solution from a professional staff, as well as a one-of-a-kind range that really you can't get anywhere else. So there's some tremendous advantages to participating in this program.
Thanks, Ryan. Jared, I'm going to throw a question at you because there's a few in the chat. If selected, what's the level of involvement or engagement from the solution providers? And I think there's a couple of questions on there with regard to travel also.
I think we're going to take that on a case-by-case basis. As Ryan mentioned, there's kind of the ongoing discussion around funding that would support something like travel. We do want to be extremely engaged with solution providers. So how that shapes up as far as kind of using tools like Teams and Zoom, and then if there are demands for a specific solution that drives some more involved interaction there, then we'd like to talk through what that might look like.
I'll jump in
Sure.
here. One chat that I think is important, just to reiterate, this kind of cohort model is, again, it's important that we all walk away with the understanding that the accelerator isn't intended to be a one and done. So this cohort is the program. Again, consider that the cohort is really the key piece of this, and we intend to have many cohorts coming in the future. There's been questions about what exactly is the timeline of that. Of course, we're heavily focused right now making sure this first cohort is launched and the process and application, all that runs smoothly, but we do intend on starting to look into the next cohort and what the focus of that will be later this year. And so cohort 2 is on its way. It's coming shortly. And our intent as we scale up, hopefully again growing the number of utilities. So utilities that are on, we're very eager to talk to you and have you join the accelerator. Now, from a solution provider standpoint, again, our goal is to grow to running many cohorts, even doing cohorts in parallel. They don't necessarily need to be done in series the way that the NREL cyber range works. We can do many experiments all simultaneously. So the question about timelines and cohorts and topics and concerns around that, again, more topics are on their way. If you don't feel that your solution fits nicely within that, please stay connected. Even if you put in an application for this cohort, it's still a nice way for us to stay engaged with you, so that as the next cohorts come, we can track that. And so again, there is another cohort coming. This isn't the only focus of this. So more is on the way. And again, expect that the next cohort will be coming out. At least we'll start developing that once this one gets launched here a little bit later this year.
Great, thanks, John. That was great information to share. So with that, I want to thank everyone for attending today. I hope you felt the level of excitement that the team's got. We've been working on this for months, and it's really exciting to see it come to a head and really get kicked off. So appreciate everyone joining today, and thanks again, and have a great day.